first we will go to welding defect. What is welding defect? Welding defect may be defined as discontinuity or discontinuities that fail to meet the minimum accepted per standard or specification. Defect may occur in excessive condition outside the accepted limit which rise to compromise the stability or the functionality of the welder structure. There are also acceptable discontinuities, the same type of discontinuity of a lesser degree might be considered harmless and acceptable. Okay, first we will go to welding defect. What is welding defect? Welding defect may be defined as discontinuity or discontinuities that fail to meet the minimum accepted per standard or specification. Defect may occur in excessive condition outside the accepted limit which rise to compromise the. As you can see on this picture, this is example of porosity. You may ask what factor that promoting to porosity. Porosity, the factor of porosity is such as improper coating on the electrode, longer arc, faster arc travel speed, too low and too high arc current, incorrect welding technique, unclean jaw surface, improper base metal composition, porosity remedies, use low hydrogen welding process, few metal height in diocider for success H2N2 atmosphere. Use preheat or increase heat input to combat high solidification rate. Clean joint surface and adjacent surface. For reducing excessive moisture, use recap procedure for baking and storing electrode. Okay, now we will go to second defect. It is crack. A crack is a fissure produced in a metal by tearing action due to inadequate preheat or fast cooling problem. Crack may also caused by shrinkage stresses in high constraint areas. Crack further classified into duration with respect to longitudinal axis of the weld, longitudinal crack, and transverse crack. As you can see on this picture, this is some example of that crack will happen to your workpiece. Hot crack. Crack can be formed immediately after welding, also called centerline or solidification crack. The causes of the hot cracking is imposition of excessive strain in restraint weld, parent metal composition with excess sulfur phosphorus, base metal contamination, inadequate filling of crater. Hot cracking remedies plant welding procedure with induced less thermal strength. Use low sulfur phosphorus containing base metal for welding. Avoid contamination of base metal.
Cold crack, delay crack. They are so called as underback crack or delay crack. Generally occurs in HAZ, heat affected zone. They lie indirectly adjacent to weld bed in HAZ area, subsurface and difficult to detect. If the cold crack propagates to surface, the crack can be seen visually. Cold cracking may occur to metal returners combined with tensile stress exceeding the fracture stress. Returners is the result of a solidification of low melting constituents. B. Phase changes. Example, formation of martensite during cooling. Factors promoting cold crack: joint restraint and high thermal severity. Hydrogen in the weld metal. Presence of impurities. Embrittlement of HAZ in low alloy steel. Weld of insufficient sectional area. Cold cracking remedies. Welding consumable must be hydrogen controlled. Pack hydrogen as recommended by electrode manufacturers. Preheat as welding procedure specification. Heat input to be maintained even for tack welding. 3. Incomplete joint penetration. when the weld metal does not extend to the required depth into the joint root, causes of incomplete penetration. Improper joint. U-joint give better than J-part joint. Too large root face. Root gap too small. Less arc current. Faster arc travel speed. Too large electrode diameter. Joint misalignment. Remedies of incomplete penetration. Use proper joint geometry. Increase root opening or use small electrode in root. Follow correct WPS welding procedure specification. These are the image of inadequate penetration due to high-low and inadequate penetration of weld groove. LOF. Weld discontinuity in which fusion did not occur between metal and fusion faces joining or adjoining weld beds. Factors promoting LOF. Improper manipulation of welding electrode. Weld joint design. Improper heat input. Surface contamination which leads slag formation and prevent fusion. LOF remedies. Minimum heat input to be maintained. Correct electrode angle. Avoid molten pools folding the arc. Proper cleaning of oxygen. Oxygen legs. 5. Inclusions. Inclusion is entrapped foreign solid materials such as slag, flux, tungsten, or oxide. Associated with lack of fusion, LOF, only occurs when any welding technique uses flux shielding. Due to improper manipulation of welding electrode and improper cleaning between multi-run. Inclusion found in weldment. Inclusion are seen on RT film. Remedies for inclusion. Better interpass cleaning. Remove heavy convex beds. Do not use electrode with damaged coating.
Okay, my name is Gabriel. I will start with undercut and underfill. Undercut is a surface discrimination with a crease in the base metal discretely adjacent to the weld. It is a condition in which the base metal have been melted away during the welding operation and there was inversion filter metal dissipated. This result is a linear groove in the base metal which may have a relatively shape convolution. Cause improper welding techniques to hide welding head. Underfill. Underfill is a condition in which the weld face or root surface instead below the exact surface of the base metal. Underfill the root will of temperatures as metal conversion or shockback. It can be caused by insoluble heating and melting of what pass during dispersion of second pass. Example travel speed. Okay, we will go number 7. Misalignment. Offset or mismatch of rods where two particles welded together are not properly aligned. It occurs because of carefulness and also due to joint different thickness. Simple of misalignment as seen on defect. We go number 8. Sputtered. always 3.0 dispersion is better as metal dispersion is building during fusion welding that not from a part of weld. Small patterning of weld metal is from the welding operation with adhere to the base metal surface. The causes of this discontinuity are high welding current which can cause excessive turbulence in the weld zone, long RC left service lateral edges, high amperes, its percent living difficulty in UTI, MTPT. Distortion in welding. What is the distortion in welding? Distortion or deformation can arise during welding as result of the not uniform expression and contraction of the weld. Are base metal during the heating and cooling cycle. Stress from in the weld as result of the change in volume. Particular in the weld is restricted by the fixed compression or the other materials supporting it. If the restraints are partly removed, the stress can cause the base material to destroy and may even result in rust or failure of concerns. Destroy can be very close to correct, so everyone is important. Two main stress in distortion. Compressive stress that cause on the area supporting the plate metal during to thermal expansion on or next to the wheel pool. Translate stress cause when the rest of the metal restart contraction or the heating area and weld metal. And the last part for me, causes of the reaction. Residual stress. Residual stress are located in the stress register in the engineering compression even if there is not internal load and this different primarily due to not inform volumetric change in the material component impressively of the of manufacturing process such as hard treatment, mechanical deformation, casting, welding, cutting, etc. However, if the maximum value of residual stress is inside the electric of the metal, residual stress can be present if the stress are higher that the blistering limit if leading to blistering, promotion and dispersion of conventional screws. Thermal cutting. Apart from welding, thermal cutting used during steel processing, chain and edging preparation also cause distortion of the base metal and induce residual stress with thermal cutting. Still, the material to be cut is reset to the injection temperature by an oxy-fuel gas filter. Welding, where a weld is laid in isolated metal and therefore hot as if cool is destroying in process stress on the weld and the burnt material hit the weld.
These are the types of welding distortions: longitudinal shrinkage, transverse shrinkage, angular distortion, longitudinal distortions or bowing or bending, rotational distortion, buckling and twisting. So as you can see, these are the example of the types of distortion. What we have here is transverse shrinkage, longitudinal shrinkage, longitudinal distortion, rotational distortion, angular distortions, and buckling distortion. How to control welding distortion? Good joint design. Well-designed joints take minimum weld volumes and do not suffer from overwelding. This is of importance when working on butt welds. Fixtures and jigs. Jigs and welding fixtures help you to maintain accuracy and reduce distortion of metals when a joint is subjected to heat shrinkage forces after cooling. The idea is that the jig or fixture will prevent the parent material moving by forcing the cooling weld to yield or give rather than the surrounding metal. Presetting. Presetting involves the assembly of the components in such a way that they will compensate for the distortion and ensure that the fabrication is dimensionally correct after finishing. Next, backstep and skip welding. When progressing in one direction in a continuous weld, the transverse contraction stresses build up, especially in butt welds. To minimize this, backstep welding techniques helps in reducing the distortion caused in this circumstance. Lastly, do not overweld. The more metal placed in a joint, the greater the shrinkage forces. Correctly sizing a weld for the requirements of the joint not only minimizes distortion but also saves weld metal and time. The amount of weld metal in a fillet weld can be minimized by the use of a flat or slightly convex bead, and in a butt joint by proper edge preparation and fit up. The excess weld metal in a highly convex bead does not increase the allowable strength in cord work, but it does increase shrinkage forces. For the conclusion, the larger the plate size, the smaller the maximum shrinkage strength magnitude to cause onset bifurcation due to wider shrinkage strength distribution and greater dimensional instability of the plate. Okay, that's all from us today, and thanks for watching. Bye.